In the previous section, we talked about one of the most important tools in the qualified worker's toolbox, the electrically safe work condition. We covered what an electrically safe work condition is, who should perform it, and when it's needed. We came up with the acronym LOC²TAG to remember the 8 steps to creating an electrically safe work condition.
L stands for locate all possible sources of energy. O for open all required disconnects. C for check that disconnecting devices are fully open or drawn out. S² for stored electrical and mechanical energy that must be released before moving ahead with work. T stands for tags and locks. Apply them to all protected devices for isolation. And A stands for absence of voltage should be verified using adequately rated test equipment. And G stands for grounds. Safely apply them in the area in which you're working.
So, you know how to create an electrically safe work condition. But what do you do when you have to work energized?
First, you have to understand that every time you choose to work energized, you're putting yourself at risk of a serious injury or fatality. In many fatality investigations, we find that an employee working energized didn't have the proper justification for doing so. If production isn't a good enough reason for working on live equipment, then what is? Let's look at a few cases where energized work is permitted.
First, a situation when de-energization is deemed dangerous. By de-energizing the circuit, we introduce another hazard or increase the risk of another potential issue. Ventilation, chemical, mechanical, and environmental hazards should all be considered. Think about a medical facility that has life support equipment tied to a circuit. That's a justification for energized work.
Second, it might be infeasible to remove power. Often, this is due to equipment design or a task being performed. If so, the facility must document this, then energized work may be permitted. For example, if you require voltage for troubleshooting, energized work might be justifiable. New equipment and technology continually redefine what tasks are justified by the rule of infeasibility. Over time, new equipment design standards will play a critical role in removing workers from the hazards and risks associated with electricity.
Third is work being performed on AC circuits and equipment operating at less than 50 volts, where there is adequate upstream overcurrent protection. Lower voltages such as 12, 24, and 48 volts still might produce life-threatening explosions.
The final justification for energized work involves equipment operation. This task focuses on opening and closing isolation and protected devices. The requirements for justifying this task are that the equipment has been properly installed and maintained, the doors are on, covers are closed, and there are no signs of impending failure. Equipment must be used for its OEM intended purpose, and the doors and covers must be secured. Remember, maintaining production is not an adequate reason to perform energized work. If you take one sentence away from this entire training, let it be this: always create an electrically safe work condition first, and if not possible, use insulated tools and wear PPE.
Energized work starts as soon as you subject yourself to an electrical hazard in the interest of observing or completing a task. Precautions should be planned and implemented in advance. Understand that as you approach a panel to work, you should be wearing the proper PPE, including shock and arc flash PPE. The simple action of operating the switch or bypassing the interlock and opening the doors places you inside the hazard approach boundaries.
Here's a quick refresher on approach boundaries. The arc flash boundary signifies the distance an arc flash hazard exists and the distance from where a hazard is crucial. If you're inside this boundary, arc flash PPE must be worn anytime an increased potential for an arc flash hazard exists. There are also two shock protection boundaries we need to be aware of. The boundary closer to the equipment is called the restricted approach boundary. When working within the restricted approach boundary, there is an increased likelihood of electrical shock, so PPE must be worn. The required distance from the hazard varies based on the voltage. The higher the voltage, the greater the boundary. This also forms the limited approach boundary, the distance at which a shock hazard exists. This boundary should never be crossed by an unqualified person unless they're advised of the hazards and escorted by a presently qualified individual. The arc flash and electrical shock boundaries are not dependent on one another.
We outlined several scenarios in which energized work is permitted. Troubleshooting is the most common in an industrial setting. Even if troubleshooting is not expected to take very long, make sure you and your team have completed pre-job planning and donned the proper PPE. Even performing diagnostics using a properly rated meter is considered a form of energized work. PPE is required in that situation too. Complex tasks such as maintenance and repair may only be performed energized when a greater hazard is created by de-energizing the circuit, or if it's impossible to de-energize due to equipment limitations. If you find yourself involved in these more complex tasks, pre-job planning and an energized work permit are required prior to starting the task.
Energized work permits are an essential part of working on energized equipment. Energized work permits help workers understand the hazards, risks, and controls of a given project. The permit process is a great way to help upper-level management to consider the risks before approving the task and justifying the need for energized work.
It's best practice to engage upper-level managers in approving energized work. They should always be made aware of the work being performed and the risks to their employees. Some facilities use a WINK system. No, it's not an acronym. With a WINK system, we're talking about facilities where workers execute energized tasks and management allows it by turning their back. This is an extremely dangerous practice because when an accident or fatality does occur, the blame falls on the employee performing the task. By asking upper-level management to sign off on an energized task, the burden of the decision and its potential outcomes falls on all parties involved, not just the worker.
Throughout this training, we've stressed the importance of an electrically safe work condition. An easy rule of thumb is if the power's on, so is your PPE. You put yourself in harm's way simply by working energized. Remember, anytime you're working energized, use insulated tools and always wear your PPE.
Now it's time for the exercise. Please turn to this page in your handbook and think back to the most recent energized tasks you performed.
Identify if they were justifiable according to the other reasons listed on the page. Complete the rest of the questions on this page.